Welcome to my video on 3D printing with the Ender Creality CR-10S. This is the first printer I bought. I'm showing a stock photo here. Also showing some of my some of the prints that I have liked more. For example, Nicholas Copernicus, famous Polish astronomer. In the Warsaw Polish capital, you have this like cultural building. So that ended up being a nice looking print. Famous World Cup, of course. World Cup, I put my name on it, and of course the cute Simon's cat with some extra, marker and coloring to make him look, as in his funny cartoons. So here are some details on the Ender CR-10S, as well as kind of like my setup here. Have it set up in the basement there, with some tools, things to clean the bed, and I also like to use hairspray on it to help the print stick to the bed. So this is an FDM, fused deposit material technology 3D printer. Approximately $400. I got it on sale for about like 10% less. And one thing that motivated me to buy this printer, it has a good size build volume. And if you kind of work out what you pay by, dividing by the volume, you're like just over 1 cent per cubic centimeter, so that ends up being a really good value. So if you use that as a metric for your printers, yeah, this one was a good value for that. A good feature that I've read that is good to have is a heated bed. This one can go up to, I think, easily up to 90 degrees Celsius. For something like PLA, 50-60 is more than sufficient. There's a mini SD card reader on that side. You can't see it, but it is there. So that's how you can transfer your 3D print G-code. So this thing can basically execute the print. It mostly comes pre-assembled. I had to put on, attach this sort of rail to that rail and a few other, like connect the wires. Most of the time, believe it or not, was installing these orange rubber like decoration things. I mean, I liked them a lot. I thought it looked really cool, give it a nice sort of neat look. Power approximately 300 watts, and it's important to know for 3D printers. I've come to learn what's the magic number. In this one, it's about 40 microns. That's the minimum step resolution. That's based on your stepper motor and the gears and the mechanical design. That's the resolution of basically the movement of your print head. So some more views of the 3D printer here. This 5 stepper motors. You got an X-axis one here that moves the print head here, that melts the plastic, feeds in the plastic here, down this tube, and then out there. So it will slide along the X-axis here. You'll see over there with that stepper motor. Y-axis motor moves the whole bed, along a belt-driven thing over here. The CR-10S has actually 2 Z-axis motors to lift up this whole rail here, like along with the print head, so that's sort of good. It's along these guide rails here. And then the 5th stepper motor is for the extruder, to basically push the plastic through the heating element. And also I'll kind of show you can see it like in action here. The bed is moving along the y-axis, this thing sliding along the x-axis, and there's the print head there. Sounds like an old dot matrix printer. If some of you older folks might know what that sounds like. Kind of shows my age. That's the first printer I used. There you see it in action, and in case you can't quite make out what I'm printing here, that ends up being this Polish eagle. So that was one of the first really big items I printed, and that took about, I think, 5 to 7 hours, believe it or not. I printed the red Polish map here, like separately. Essential tools, I recommend you buy different nozzle heads. It comes with, standard 0.4, that's kind of standard out there. You can get much better detail with the 0.2 millimeter nozzle. I guess this picture doesn't really show it, but it's there. I personally have not had much luck trying to use this. My nozzle keeps clogging, but most of the stuff I do, I'm great using standard. I've also used the 0.8 millimeter one. Your 3D prints, although you lose detail, they can print so much faster, like almost a factor of 8 times faster, because your layer height is faster, so that gives you some speed improvement, and the amount of plastic that goes down due to this area being so much larger. Tools here, the Creality actually came with these snippers here and this thing to help peel off the plastic because it sticks to the bed just from the heat alone, or if you use, in my case, like hairspray. This is good too to sort of do some post cleaning like afterwards, and as well as the sanding. And this thing here I just bought from eBay, about 10 bucks. You can buy it like yourself. Like I said, it's very handy to have these extra nozzles. Filament of materials. So I've started off with, like most people, using PLA, polylactic acid. It's a thermoplastic. It'll melt at a certain temperature, approximately 200 degrees Celsius is the printing temperature. This material, they claim, is made from renewable resources, so it includes things like cornstarch and sugar cane. So having said that, it's technically biodegradable, so if you leave it outside, there's some interesting videos I've seen that 1 year later it falls apart. So we'll see how my prints last. In terms of cost of the plastics, they're in the range, 15 to 20, sometimes up to $30 per 1 kilogram spool here. There's many different materials. I haven't tried these yet. PETG, flexible plastic, like our ABS. It's on my to-do list. One important thing here, especially when you're first starting out, you want to avoid like tangles. What I mean by tangling here is somehow, like if you're not careful with the end, it'll somehow find its way in here, that if it's loose, it'll somehow get underneath some wire. Then as you're printing out, it gets caught and then stuck, and then no more plastic will come out of your 3D printer and your 3D printer fails. So there's a reason they have sort of these things here, and you can also see them there, that whenever you're storing it and holding it, keep track of the edge there. In case you're curious, what's the size of this? The diameter is 1.75 millimeter. That's the standard size. So that melts down to your print nozzle diameter, 0.4. So when you start off, where can you download 3D models? You probably just want to download something and print something right away. So my favorite site is Thingiverse, made by MakerBot. I like, I've printed quite a few Star Trek ships, so that's kind of what's shown here. Another good site, Yegi, you can find a lot of stuff there. You see it links a lot to Thingiverse. Another site that's more SketchUp based, 3D Warehouse, so you can use this, you can download SketchUp, and it's possible to convert from that program. Some other sites, there's my Mini Factory. I've even found it useful just to do a Google image search for whatever I'm looking for, ship or some item. Just type in the name of the item plus STL or 3D print, and you might be able to find a useful link there. At the end of the day, wherever you download from, you want what's called an STL file, stereo lithography. In terms of softwares like editing and modeling, I've come to like a lot, like Tinkercad. At first I thought it was too simple and you can't do much, but I've been able to use it quite well. It's very handy. You can import and export STL files. On importing, I think there's a 25 megabyte size limit. There's ways to get around that. For example, I've used the 3D builder built in with Windows 10. You know, I can actually, there's a very complicated big size model. I can reduce the number of polygons, which reduces the size. I found this useful to also do smoothing, maybe some split and mirror like effect there for the model, and also conversion as well. Another more like programming sort of style on how to build like a model, OpenSCAD. You kind of write in your text or code to build in some sort of model. In this case, you have the sphere. You can specify the size, how many longitude, latitude lines, and so forth, and it'll create that. And you can also export to STL. And of course, there's SketchUp. So this gives you the added feature of adding like textures, so you can do some really cool 3D modeling here. You know, it's not free, but you can get a 30-day free trial. So I found it okay. I personally find the camera and how you use the mouse is kind of awkward, especially once you get used to one sort of software. To go to another requires some mental mapping. Another very important software, once you have your STL file, you need to use some sort of slicer. You know, this is what actually will translate to what's called a gcode that your 3D printer will read to execute its path and extrude the plastic and move around. I've started off with Ultimaker Cura. I find it quite good. It's quite handy. You know, it'll show you kind of example what the final print would look like, you know, layer by layer, give you a approximate time and mass estimates, you know, and even how long the filament is. So it's going to make a long tool path, very long spaghetti noodle segments, and you know, some important things, you know, take some practice with the software to learn, okay, how should I like orient, you know, or even scale my print. You can print multiple objects, you know, you can print them all layer by layer or one at a time. You need to specify things like what's the nozzle size, what's my quality in terms of the layer height. This should be a multiple of the magic number. You know, you can specify the print material, bed adhesion options, for example, the temperature of the heated bed, and also do you want to add a brim? In this case, I did want to, because I would print something that would be primarily vertical, and I wanted something to help it stick and not fall over. There are more options, of course, and supports. You know, take some practice to learn, okay, where do I want supports? You can block supports in some regions. You can specify what angle and how close. So here you see I have supports here to print something that is hollow inside there. Infill per percentage, you're not going to necessarily print. Say you had a cube, you don't want to print the solid cube inside. You want some gap in air, so you can choose that, and even the style of it, and you can specify for the shell what's its thickness. Some interesting options I've had some interesting usage for. You can expand the shell by some size, say 0.4 millimeter. If you're printing something very small that has small details, you can just make it all kind of fatter with that option. And fuzzy skin is pretty cool too for some things. So here I kind of show you a video there of, if I can get this going. There it goes. Slight technical challenge, but we're back on track. So here I'm like manually sliding up and down to see layer by layer. So I start with the first layer, kind of manually scroll through here. So you see how it makes the first layer, and then slide through all the other ones. So this will give you an idea how it would print. It's not as fast as this in real time, of course, but it will give you an idea how the whole thing will print. So it's useful to do this to make sure that okay, you haven't missed anything. sometimes you miss the support, and that will mess it up because you can't just build like on the air. So here I'll kind of summarize the overall process of 3D printing here. You'll either make your own model, Tinkercad or something else, or you'll download one and say you want to customize one. So here I have school bus. You can import that into Tinkercad and then, for example, add a name. Put it in there. That's simple to do, and then either of these three options, when you're kind of done, you want to export or convert to STL. That's an important step. Then from that, you would load in your STL in your slicing software to generate your G-code. I described about that in a slide before. Then you need to transfer your G-code to your 3D printer. I'm fine using the mini SD card-like approach. There are interesting options, very cool looking, through Wi-Fi LAN, using Raspberry Pi connected to your 3D printer, so you can do some online viewing of the 3D print, like as it's going. Something I need to try in future. And right before you want to kind of get everything going, you want to make sure you do your preps and checks. Make sure your nozzle's clean, particularly if you're change plastics. You want to make sure there's none of the old color plastic kind of in there. That would mess up the color. I learned that once or twice. Make sure you have enough filament and it's untangled. Do you need some bed adhesion stuff? Glue stick, hairspray, and the most important, bed alignment. You're adjusting each of these 4 lobs. You don't necessarily have to do this on every print, but it's good to check every maybe 4 or 5 prints. If you have a very long print, maybe it's good to check this. You need to get the spacing right to do that. Then you would get going, press start. It's going to basically heat up the nozzle and bed first. That usually takes, no more than a few minutes, maybe a minute, depending on your bed temperature. Then once it's going, probably have to wait a long time. Easily prints can go, something that's like 50 grams, 100 grams, you might be waiting easily 10-15 hours, depending on the complexity. Then once you're done, post cleanup. If there's any extra material on the supports or brim, you want to get rid of those, and you might have little nerds or knobs left. You want to kind of cut them off or sand them off, and of course you're welcome to do any painting as well. So that ends my video here. I hope you enjoyed that. Some tips and sort of my experience with the printer so far.